I'm the data science director at Masternaut. I've been doing that role for about 2 years. And when I was hired in January 2018, I was the very first data science employee. And so part of my role, and a big part of the early stages, was to build that team up. And Masternaut itself had never done anything like that before. And I'm just going to take you through some of the early stage decisions we made around the data structures, and then go through the hiring process to describe how it is that I evaluate potential candidates. So you're probably wondering who Masternaut are, because it's not a household name by any means. What we do is we're a vehicle telematics company. Okay, so what you see here on this visualization is an hour snapshot. If you imagine every vehicle that we track leaves a little trail like an ant, this is what 1 hour looks like on a typical Tuesday. This is like I think it's 10 o'clock on a Tuesday. So we've got a lot of coverage across Europe, but mainly focused in the UK and France. In total, we track around 250,000 vehicles, almost entirely commercial vehicles, and that includes some seriously large companies. So think big supermarkets and their delivery fleets, chilled vans going to homes, that kind of thing. And the way we do that is by installing devices in their fleet vehicles, capturing data from that, and then using that to give them services. And part of those services now include data science, which is what I'm going to talk to you about. So Masternaut have been doing this for about 20 years, right? And for telematics, that's an extremely long time. That's like when mobile phones weren't even that common, really. Well, like 20 years ago, I guess they were, but it was certainly relatively new to the telematic industry. So the way we do that, the way we've done that historically, is by installing these boxes into the commercial vehicles. They go under the dashboard. We then tap in using this clip at the bottom to something called the CAN bus, which is an internal network of sensors within the vehicle that measures everything from fuel usage, brake pressure, brake pad wear, engine indicator lights, all kinds of information. Anything going through the engine control unit goes through these wires. And we just tap on with a little clip, just like in the spy movies, and we just read passively the induction readings from that, from the current in those wires. So it's totally non-intrusive, and we get very good data capture on the vehicle. What kind of stuff do we capture? Well, the core telematic data that pretty much any telematic company captures is this stuff at the top left. So you're looking at GPS position, time and date, speed, obviously, which comes from the GPS, compass bearing, and also acceleration and braking, which you can infer from an accelerometer on the chip. However, because we've got that CAN clip, we capture a lot more as well. And this is where the data science gets a lot more exciting. So we can capture the CAN speed, which is exactly what the odometer shows. So it's way more precise than a GPS speed and much higher frequency. Think like kilohertz rather than 1 every 5 seconds. Odometer readings, engine ignition on and off events, the precise amount of fuel used, all kinds of readings like that from the CAN bus. We also, when we install the device in the vehicle, capture things like the make and model, the vehicle registration number, vehicle identification number, and loads of stats about the vehicle. And again, a lot of telematics these days is from a mobile phone, like Waze or Google Maps will be capturing telematic data. They don't know what vehicle you're driving. They don't know what company you work for. So this is actually quite useful information for analysis purposes. And then finally, we've got maintenance data. So stuff about the malfunction indicator lamp, the MIL, stuff like that, distance to next service. All of this is also reported and we capture. So why on earth were Masternaut doing that for 20 years and not doing any data science on a data stream that rich? That's incredibly detailed data at high frequency across some of the biggest companies in Europe. It's a really good question. I don't know the answer, but I'm very glad that in 2018 they decided to form a team. But because it was brand new, there was nothing to go on, right? We had the existing company from a fairly old tech stack because it was 20 years old, and we had to build a data science functionality out from that. So step one, before you can even go and hire people, it was necessary to build an environment. I'm just going to spend a few slides now doing some, probably for some people, they're quite boring data pipeline stuff, but about how we restructure the data to make data science actually possible and explain why it wasn't under the old system. So the way we store data in the past, and still do in our core product, is with a NoSQL database. So that's probably very common for a lot of you here. But really what that means is, imagine a whole load of documents, just like this one, on some server's hard drive somewhere, right? This is a JSON document. It's actually BSON because it's stored as binary, but that's a technical detail. And it consists of keys and values, right? So key, ID, value, whatever the ID is, etc. And it's nested, so you can have sub-documents, and you can have all kinds of flexible data fields in there. Okay? It's extremely flexible, and it's extremely good. So let's say you wanted to find out where a vehicle was right now. You just pull up one of those documents, and it tells you everything you need to know. It tells you the vehicle, the identifier, the make, the model, the fuel used, the current speed. So if you want where your vehicles are on a map, this document is perfect. You can index it, and you can retrieve that document in a millisecond or less, right? So what we did were 4 main things, right? And we didn't invent any of this. I'm not trying to take credit for this. This is all standard stuff that any big data company will be doing, especially time series data companies. So distribute the computing. In other words, don't have one database, one monolithic database answering these problems. That's really important. Partitioning. Segregate your data into chunks so that you only have to read one chunk out of many. Columnar storage. Instead of having to scan the entire document for that fuel field and then read the fuel field, why not have one document with all the fuel used for a company, or all the fuel used for a vehicle, or some form like that? That's called columnar storage, and it makes it much more efficient for narrow and deep queries where you only want a few fields, but you want a huge number of them. The opposite of that is shallow and wide, which is what the BSON, the NoSQL database earlier, was optimized for. And then finally, compression. We've got a huge amount of data here, terabytes of data for a typical query. If you can compress it in an intelligent way, you can, again, massively reduce the I/O overhead, and especially when it's in the cloud and distributed, that can make a big difference too. Do all that, and you get massive speed up and also significant savings. So I'm just going to visualize a little bit what these steps look like. So to begin with, imagine you were doing a naive query. Here's all those files with all those bits of information. You read them all, right? And then you find the numbers that are relevant after applying the filtering or whatever, and then you return your result. Super slow. You've got to read a huge amount of data. By going distributed, you can split the task up into loads of handlers. Here I've displayed 5, but Athena, which is what we use, which is an AWS service, can do this across 10,000 nodes if it needs to. The scale in AWS is insane. So that's the partitioning side of things. You've immediately divided the work by 5 in this case. Then with partitioning, again, a fairly trivial technique. If you make sure the data is stored in an appropriate way, you only have to read the file you need, and you don't even have to touch the rest. So again, massively reducing the I/O overhead and the amount of calculations you've got to do. Columnar storage, instead of reading the whole file, why not just read the chunk of the file that contains the data you need? If you've made the file in an appropriate way so that you can read that chunk of data in one step, you can do that. You can just start at bytes 1,000,000 or whatever it is, and then read the section you need. And then finally, compression, make it nice and skinny. That way, you have to read and transmit less data between your nodes when answering these questions. So after doing all of that, we went from so this is for a typical query where I was doing a visualization video. It would take approximately 6 hours on a optimized, indexed MongoDB server, which is a NoSQL server, the original tech stack, at a cost of perhaps $3 in compute and storage. Go through those steps, and you end up with massive, massive improvements. We got a 99.96% reduction in time for that particular query, and the price went down by whatever the factor that is, nearly 1,000, like 700 or something. So huge, huge improvements in both cost and time. And this can't be emphasized enough. Having done this made it possible to answer the kind of data science queries that this business had, whereas before, you would carefully craft your pipeline in MongoDB and wait 3 days to get your results. And if it was wrong, your iteration cycle was so slow that it meant data science was almost impossible, unless you got it right first time every time, which of course never happens. So having set all that up, and that was with a lot of help from the AWS team as well, we transferred all our data into that format. And then it came up to the next task, which was hiring the team. Okay, so this is where I'm going to spend the bulk of this particular talk, because it's got the most, what I found, the most learnings in it. So for about 3 months, we didn't really have any success hiring anybody. Our approach was wrong, right? Hiring a good quality data scientist is actually pretty hard. There's not that many of them out there, and it was really challenging for us. And we were getting a lot of rejections. People were going to other companies. They just weren't interested in Masternaut for whatever reason. So clearly there was something wrong with our approach. And then what we found out was the key was trying to get them excited to join our company, try and get them a bit more pumped up about it. And really, the way we did that was to make the process longer and harder. And it sounds counterintuitive, but this is a really good way to gain buy-in from potential candidates. Okay? So I'm going to go through what the final process that we've come up with looks like. This is the team at the moment. It's still very small. There's 5 of us. We're hiring 2 more right now, and there's also a team out in Slovakia as well who are doing some of the background support. The kind of people we go for are normally researchers of some shape or form. So, I mean, Maciej, he's now a senior data scientist, actually. He's got a particle physics background. Martha was a computational neuroscientist. Geoff did loads of oil and gas work, basically using ultrasound to map out oil fields and do data science on that. Albert, he's my boss. He's an ex-consultant. He doesn't really do any coding or data science, but he kind of directs me to certain directions. So this is the team. It's actually growing. It's probably about out here now, but this was when I did the presentation. This is what it was. So, what were the challenges? Well, there's a number of things that made it easy, a number of things that made it hard. So, really, for me, the main thing that made it easy is that a lot of the skills that I was looking for, I was already quite familiar with. Right? I knew the coding, I knew the various libraries that we used. I had a really good idea about what the team would be doing day to day, and that similarity of skill set made the process for me a lot easier. I can imagine if you were a manager trying to establish a team like this, or someone like Albert who doesn't have that kind of background, it would be extremely difficult, I think, to be able to tell a good candidate from an average candidate without that. People are normally very honest. People from a research background, typically they get a lot of feedback throughout their PhD, for example, or throughout their research career, and quite frank, harsh feedback. And that's good, because that's kind of how I operate by default, unfortunately. But it means that they're extremely honest, even in the interview stage. Right? And this is something we'll come on to more a bit later. There's a lot of people looking for roles, but the counterpoint of that is there's so many pretenders. Right? There are so many people who say, I'm a data scientist, I'm applying for a data science job. They've never done it before. They don't have the skills. What they've got is maybe they've done a couple of Kaggle exercises or something. They know a few of the techniques, but there's no depth to their knowledge, right? And that can make it really quite hard in a short interview process to find out the candidates like that. So yeah, the other things are also true. Right. So the process I've split up here into these 5 stages. Right? And along here is roughly what, for me, the pipeline looks like in terms of the shape of that funnel. Okay? First of all, the CV review. Okay? So this step here, there's 2 ways you can do it. One is you can go to a recruitment agency who specializes in data science, yeah? And you can get them to give you a bunch of CVs. Right? The idea there is instead of getting 100 and going down to 20, a really good one, hopefully you're getting 30 and going down to 20, and therefore you should save time. Right? The price you pay for that is between 10 and 15% of first-year salary at the point of hire, so it's not cheap. And what I've found when working with several agencies is normally they're not actually technical enough to be able to discriminate quality candidates. They don't really know what they're talking about when it comes to data science. They ask for things like your tech stack, but they just pass it on verbatim, and they don't really care that much about how good a fit the candidate is, right? So you don't see 30 to 20, you see maybe 80 to 20. So the value you're getting out of a recruiter from a hiring point of view is quite low. Second downside of recruiters is not only do they give you the CVs, they give it to a bunch of other companies too. Okay, that's great if you want a job. It's really bad if you want to hire, right? That means you lose candidates to other companies. You're competing in parallel with lots of other companies for quality candidates. Right, so let's go through a couple of CVs so you can see what a good one's like and what a bad one's like from my perspective, okay? So what you want to look for are specifics. Super important because, like I said earlier, you want to filter out the pretenders, okay? So something like this, I've specific languages, specific libraries within that language, specific techniques, specific data architectures and infrastructure, things like that are good. You want specifics, and it helps in the next stage as well. You want to look for a high level of compatibility with your stack, yeah, as much as possible. But bear in mind, I think with any data science team, there's always going to be quite a big chunk of on-the-job learning. Okay, the data fields you're going to have to become familiar with, the particulars of the stack, and maybe some homemade libraries that the team use are all going to have to be learnt. Like even the best data scientists that I hired in that list took about 2 months to get up to speed really with the way we operate. That might be simpler if you use a more common framework like maybe Dataform have, I don't know. But if you've got a custom stack like us, then it takes time. And then finally, I found that experience is actually a pretty poor predictor of how they'll do in later stages. So I tend to emphasize more speed of learning, fluid intelligence, those kinds of attributes, rather than saying I've done this for 5 years with one company, right? That to me has proven to be a poor indicator of a successful candidate. So here's an example CV. I'm not expecting you to read all this. I'm just going to pull out a couple of points. Okay. So this, from my perspective, is a bad CV, right? This is an example of a pretender. Okay. So first of all, they speak a lot of languages. That's not impossible, yeah, but it's pretty unlikely. You combine that with the fact that they have every knowledge, like pretty much every skill under the sun, including being a fiction and non-fiction writer, a teacher, holistic knowledge of informatics. Terms like this should immediately raise a red flag in your mind, okay? This is someone who really is quite confident, obviously, to write a CV like this, but it's highly unlikely, not impossible, it's highly unlikely that they're good at all these things, right? This is way too broad. And for me, this would be a CV that just never would go past this stage. This would be one of those 8 out of 10 that get rejected. So not credible, self-congratulatory, no focus, right? Look for specifics. This is an example of a better CV, not perfect, okay? Again, it's very long, and I'm not expecting you to read it, but things that it does well, okay? So there's a whole section here on dimensionality reduction, which is a family of techniques in data science. To me, a bit wordy, but I'd rather know that and see specifics of what they've done than just have a bullet point saying like scikit-learn or something. Here it's way more specific. They also mention loads of specific tools and languages they use for each individual task. That's a very good thing. And just the language used makes it clear that they're quite familiar with this kind of analysis. Okay, so the bad things are they don't really say results, right? I would love to read something like model deployed resulting in a saving of so and so, or model deployed resulting in a revenue increase of so and so. That would be even better, but they don't have that here. And the other thing that I flagged on this one is the fact that they've only been in the job a year. Now a year is not terrible, it's better than 6 months. But if someone's been doing this kind of work in this kind of detail and wants to leave after a year, that's definitely something you want to ask them about in the next stage, in the face-to-face. But for me, this would be an example of a CV that would make it, personally. OK, so that gets us down to about 20 out of 100 candidates at this point, okay? Assuming you do your own CV searching and reviews, which I recommend. The next step for me is a phone interview. So I would contact them via email or whatever method mentioned on the CV, and I would arrange a time and date for a half-hour phone interview. Internally, I would budget at least 60 minutes of time because these interviews often overrun. But by stating it at half an hour, you've got an easy get-out if it turns out the candidate isn't very good without being so rude that you would impact the reputation of the company. So first of all, again, Masternaut no one knows, so obviously 5-minute introduction where you introduce it as a business and you describe at very broad strokes what data science means at Masternaut. After that, I tend to go straight into their CV and I pick one thing that I want to talk to them about. Okay? And again, this is about trying to find out if they actually are good at what they say they're good at, because a lot of people lie on CVs. So I will ask them basically these 4 questions, right? If it's I try and pick something like a modeling challenge, because those are quite good for Q&A, two-way Q&A. And I'm normally interested in how did you get the data? What form was it in? What data cleaning did you do? What pre-processing steps and why? Did you standardize and scale your data? If so, what scaling method? What about outliers? All that kind of stuff. And there you're looking for someone who doesn't just blindly follow some algorithm or tutorial online, and instead understands the business context of the data that they're querying. Finally, I go straight to the output. So there's obviously a whole bunch of work in the middle about actually how you transform and analyze this data. But I want to know, once an answer was created, whether it's a classification, a prediction, I don't know, something like that, I want to know how that was shared and who with, right? What output is it taken? That's from a technical perspective. Maybe it was delivered via a RESTful API that was used by the dev team. Maybe it was a report or a CSV or an Excel file, yeah? I'd like to know what form it's in, and also how they share it. So that's quite important because that's something that a lot of data scientists, even very good ones, they're quite insular in their focus, and they're not necessarily the right people to go out and share their results eagerly. So digging into that's quite important for me. And then finally, I want to go through their motivation and history. Why do they want to be a data scientist? Do they like data? Obviously, they should be liking data. Are they changing from a different role? This would be a perfect example to talk about that previous candidate with the 1-year experience. Why are they leaving? Was it a problem with the company? Was it downsizing? I don't know. Dig into that and their motivation. Okay, especially if you're contacting people rather than them coming to you with their CVs. This is actually quite a good way to flip the script a little bit rather than just chasing them all the time. And if they're excited by the first bit of challenge that you've given them, which is often the case, then this is a chance for them to kind of sell themselves a little bit as well. So things that can go wrong here, it's a super long list, but the common ones I've seen, amazingly, are people actually blame other people for when something goes wrong. Like they do some project and some work. The output was never used for some reason, and they say, oh yeah, well sales never used it because the manager wasn't a believer or something. To me, that's I don't know. It's a personal thing. I don't really like that. I think that's a negative in terms of working in a team environment. Doesn't mean they're bad at the job, but for me that's a negative. Misuse of jargon is a real giveaway. A lot of times people, especially if they're from a company where there's not that much of a data team, they're known as like the data guy in the business or something like that. If they start misusing jargon, it's a real tell that actually they're not that familiar with what they're talking about. Even if they nail going through the specifics of their one project, there's very often slips where they just use terms in completely inappropriate ways. And then confusion or memory issues is also super common. This is actually a tell for if they didn't do the work themselves. Okay, so a lot of candidates will claim credit for work they were only on the fringe of, right? So let's say there was a data team of 5 or 10 people, and it was amazing and it did really well, and they're able to nail this like early stage here with a 15-minute deep dive. If they only did like some tangential support on that or something like this, they often get confused or have memory issues when you start drilling into some of the detail of model implementation or something like that. So those are things to watch out for. So it often overruns, but normally about half an hour is what I try to aim for the first interview. 50% of people make it through that, so not a bad pass rate, really, at that phone interview. And then the next stage is the face-to-face, right? Which is the first time, obviously, you meet the candidate, you get them into the office. One thing to note, try and do this all as rapidly as possible if you're hiring, right? The last thing you want is to have like a week-long lag between, the arrangement of a phone interview and then the phone interview and then another week for the face-to-face. That just doesn't build that excitement that I was talking about earlier about them actually wanting the job, which is essential to actually get them to convert. So in the face-to-face, my formula, 60 minutes, pleasantries at the beginning. It's actually more important than it sounds, I think, because someone who's a bit chatty here, again, it correlates a little bit more with people who are a bit more on the sort of pretender scale for data science. So that can actually be, if someone spends ages chatting at the beginning and is a bit of a salesman, that to me, that kind of is I would want to check a bit deeper then on the technical side because it's more likely they will have passed the phone interview while not really knowing what they're talking about. But then 20 minutes, really, really go deep on some technical part of their job. Okay, so again, go through the CV, find a different example. The difference between this and the phone interview is you want to do it on a wall. So we've got, like at our business, we've got some whole walls or whiteboards. There's that special paint. Get them up there, get them drawing diagrams, get them, ask them much more technical, challenging problems, a lot more like brain teasery style stuff. Challenge them about their approach. And do that to try and, again, this is trying to find out if they really do understand what they're talking about or if they're just a tangential team member. The next 20 minutes is the other way around. I will introduce to them some work that we're doing at Masternaut. So, for example, it might be, a better collision detection algorithm, right? So our devices have a 3D accelerometer in it. So we get 400 hertz data off that. So we've got these waveforms for each of these accelerometers. How do you detect a collision? That's the challenge my team would get from the product management team. So normally that would be maybe a 6-week project or something like that to implement a sort of alpha version of this. And I would walk them through the brief we've had and some of the work we've done, and then ask them what they think. How would you compress the data if necessary? How would you reduce the dimensions if you want to? What are the pros and cons of different models, from neural nets to support vector classifiers, whatever the different options are, and see if they understand these terms and see if they have some opinion about which ones are best, right? So that's a really great way to see what it would be like to work with them if they did get the job. But Obviously, we do this every day. They're brand new to the business. You've got to do this with a lot of helping in terms of the way the data's structured, and you've got to do a lot of prompts as well, just to get anything useful out of people for something as technical as that in the pressure of a face-to-face interview. So you just got to bear that in mind as well. And then finally, at the end, hopefully it's a good candidate. They've done really well. They've responded well to the challenge. They've nailed the technical questions. At that point there, you want to build excitement. You want to get them really pumped up. You want to say all this stuff in your pipeline that you're going to be working on. And it's in our case, like we've got a lot of great data. You know, that's not that hard to do. And if you can get them excited, you're very much more likely to convert at the final stage, whereas before we didn't, like I said, over those first 3 months. Okay. After that is the most important part, right? Literally everybody who gets a face-to-face interview also does a coding skills test, right, at Masternaut. So this is something I wrote about a year ago. It's a 2-hour test. That's what I tell them it takes. If you're good, it takes about 40 minutes. We don't strictly time it or anything. So a lot of companies, what they'll do is they'll send you a test at 6 and want it back by 8 or something like that. They'll pre-arrange that time slot so they know you're available. I don't do that. I generally give them a day or two, and I say it should be 2 hours, but just use your judgment. The design on this test is supposed to mirror as much as possible a real-world data science project at Masternaut. So really, it's got these. It tests these 4 things, right? The data ingestion, data cleaning. I provide them a notebook with a whole load of markdown, which describes all the various bits of analysis I want them to do, and a CSV file to load, right? And it's all done with pandas, sklearn, matplotlib, and just and core native Python. So no special libraries required. Then data manipulation, statistics. They're not, test their statistical knowledge a little bit, and then finally a modeling challenge at the end, which is about classifying asset types. Is that vehicle a van or a car or an HGV? And again, yeah, it uses the same stack that we use day to day. So if they can nail this, that's a really strong indicator that they're going to be good at the job. And then if they succeed there, that's about a 20%, again, a massive cut there on the data science skills test. They would then go into final interview. Final interview, really at this stage, you want to hire them, right? If they've done well on all those previous stages, they're a good candidate. So here, it's all about all the more boring HR-y stuff, talking about pay and compensation, bonus structures, pensions, you name it, whatever's important to them as a candidate. Okay, so in summary, what are we... Like I've been mentioning throughout the speech, emotional buy-in from the candidate is really important. If they're good, you want to make sure they accept your offer. And good candidates really care as much as about the data they're using, the techniques they're using, the flexibility in the team. They care about that actually as much, often as much as pay. One of my data scientists had an offer for 10 grand more per year in salary, but they didn't take it purely because they thought the opportunities and the research from the analysis that we were doing was exciting enough to make the difference. So that's why, again, you want to try and build the enthusiasm throughout this process. Good. That's it. Thanks very much. It's a really bad ratio. It takes a lot of time, and I'm sure this isn't optimal. Now, just like the previous question, I'm certain, any data scientist who's familiar with stats would be certain that after doing a bunch of hires like this, you've missed great candidates at this massive drop here. Yeah, CVs are really, the signal to noise on a CV is atrocious. Yeah, it's a page or maybe 5 pages of data. It's handwritten. It's all different kinds of formats. It's not standardized. It can be full of lies. It can be people who are very shy about their achievements. The spread and the range and the noise in that data is insane, right? So yeah, the drop off is huge, and there's going to be a lot of false rejections there, or false negatives, or whatever you want to. I'm using all this data science terminology, but. There'll be a lot of missed opportunities. There. How to fix that is a real challenge. I've definitely got better over the past year at this process. It's only been probably 10% of my working time hiring, but I've definitely got better at it. There's a lot more improvement to do though. This to me, looking at this as a process and a funnel, that would be the obvious place to go, which is why recently I've been using recruiters who are supposedly specialists in AWS, Python, data science. I get an email literally every day from a recruiter who's got all those things that they're specializing in. Often the entire firm is a data science specialist recruiter. But the quality I've seen, like I said earlier, that it should be like 25 or 30 to 20, if you use a recruiter. The quality I've seen is just not there. The last set, I got 8 people down to this stage here. and they all dropped out. All but one dropped out at this stage from the recruiters. So there's some selection bias going on there or something, I don't know. So it's not a well-defined term, okay? So data science and data analyst, there's a lot of crossover between those two labels, right? So the way I've described this before, when people say, well, what is data science and what is it, how is it different from data analytics, is I say a data scientist is very much more code-based. They're going to be writing lines of code, their own code, whereas a data analyst typically, and again, a lot of crossover, but typically will be more using tools like ClickView, Tableau, Power BI, other visualization tools on pre-built solutions. Okay, so that's probably the primary difference. A lot of people, when they go into data science, are thinking, oh, it's all about modeling, machine learning, AI, right? And that's definitely a component of it. But really, I find in the work that we do, it's, and this is not dissimilar to other companies, it's probably like 30–40% of the job, right? The rest of it is just core, good quality statistics, understanding your data fields, understanding your data cleaning process, and just doing thorough analysis in a normal statistical way. So 25% of our workload in the team is client work, right? So client work would mean going to a manufacturer, one of the big manufacturers in Europe, for example, travel to them, help them design, use telematic data to help them design a better electric van, right? What are the battery capacities? Which industries would it be useful for? What about urban delivery versus rural delivery, coastal areas, mountain regions, modeling energy usage over time? Those kind of questions, working with clients, are very similar to a consulting type workload, right? And they require those skills that you talked about. So for me, it's very much a bonus. So normally the way I do that is I've got one data scientist who's got that skill set, the oil and gas guy. The others are like super technical and pack every sentence with caveats. This is what you see with PhDs, right? They spent 4 years trying to defend their one piece of research. So every time they come out with a conclusion, they pack it with caveats, just in case they get attacked. So you've got to beat that out of them a little bit, or hire non-PhDs. So it's really important, but for me, there's enough people with that skill set already in Masternaut. I'd much rather they were really solid at the analysis. But if they can do that, brilliant. They can come with me and do those meetings.